So here we have a trig function graphed, and we want to figure out the equation of this with a cosine. So the first thing I'm going to do is figure out where the baseline is, find the line that this is oscillating about. It goes right through the middle, and it looks like it's right here. We can see that it goes as high as 1, 2, 3, 4 above the baseline, or as low as 1, 2, 3, 4 below the baseline. So we know that everything is shifted up 1. So we've got B on the end is going to be a plus 1. We also know A because A is the amplitude, and we go up 4 and down 4 above and below the baseline. So now we need to figure out our omega and our phi. The omega is determined by what the period is. So let's figure out what the period is. It looks like I'm at a minimum right here when x is 0. So if I go over and find the next minimum, I can see how far apart they are, and it looks like they are pi over 2 apart. So my period is pi over 2, and period is found by taking 2 pi over omega, and that needs to equal pi over 2. So now I can figure out what omega needs to be. It needs to be a 4, so that when I reduce this, I will have pi over 2. You could also take the algebraic steps to solve for omega. And if you did that, you'd have 2 pi over omega equals pi over 2, and you would multiply both sides by omega. And then I would multiply this side by 2 over pi, and this side by 2 over pi, so the 2 over pi's cancel here. The pi's cancel here, and I'm left with omega equaling 4, which is what we found right here. So that means in front of the x here we need a 4 and then x. Now if we wanted to figure out our phase angle, we first need to find our phase shift by observing the graph. And normally at 0, cosine is at its maximum here. Well, actually it is at its minimum, so we wouldn't need a phase angle if we just put a negative on here, because a negative would reflect it. We don't need to shift it right or left if we just reflect it over that baseline. So putting a -4 right here will give us the correct equation.